Alright, so now we're going to have a look at another question. This comes from a uni Calc 1 2014 paper. This is a pretty easy one, it's quite a short one. It's easy if you do it the right way, it could be really difficult or near impossible if you do it the wrong way. So we need to find an angle between a three-dimensional vector 1, 0, 1 and the positive x-axis. This vector is really interesting. It's 1, 0, 1. That means one of its dimensions is 0. And that means the whole problem is going to become much easier than it would if it was, say, 1, 1, 1 or 3, 1, 2 or something like that. That would be a much harder problem. We're not going to draw this in 3D, right? You could try drawing it in 3D. So you could sort of draw your y-axis, your x-axis, your z-axis, and then try drawing it here. This is a 2D pictorial representation of a 3D graph. They can be good, but they can be really hard to draw. Because y is 0, it actually only needs to be drawn in the xz plane. So if we draw a plane here, we'll make this axis x and this axis z. So this is 1, this is 1. This vector goes from the origin to the point 1, 1, which is here. The y plane comes out of the page through the origin towards us or away from us, but its y coordinate is 0, so we don't actually care about that. So it looks like this in the xz plane, and it has no y movement. There's no pulling it towards us or pushing it away from us. So the question is now, what is the angle between this vector and the positive x-axis? It's this angle in here, which must be 45 degrees. So 45 degrees is pi on 4. So therefore the answer has to be A, which is pi on 4. Again, this is really easy if you do it right, but if you try setting up the positive x-axis as, say, for example, a vector, and you say that it's n, 0, 0, and then you try using dot products of the vector 1, 0, 1 with n, 0, 0, and then using the definitions of the dot products to find the angles, that will work. You're just making it harder than it needs to be. You just need to think about this problem correctly. There is no y movement in the y-axis, right? The y is 0. It's only in the xz plane. So 45 degrees, pi on 4 has to be the answer.